In this video I'm just going to do some tests on the new antenna tuning unit I've built. I'm going to attach a variable resistor on the output, and I'm going to try and match that resistance to 50 ohms. In order to do that, I'm going to use one of my antenna noise bridges. I'm going to set it to 50 ohms and resistive. This is purely a matching a pure resistance. Of course, you can also match reactive loads as well, but just for this demonstration I'll stick to resistors to keep it brief. So on the output connector of the tuning unit I've got a pot which goes from near 0 to 2.5K, and I'm just going to set the resistance and then see how the antenna tuning unit matches whatever resistance I've set up on the pot to 50 ohms. So that's just a look at the back of the tuning unit. The detector for the noise bridge, I'm just going to use the IC706 on the AM mode. There it is down there. I'm just going to do the range from 160 metres to 10 metres. I've just currently got it set at 28.5, so I'll try that one first. So I've set the pot at 8 ohms. It's a very low impedance or resistance, so I'm going to try and match 8 ohms, an 8 ohm antenna, to 50 ohms using this tuning unit. So I'll just turn the noise up on the IC706. It's tuned at 28.5, and we have a very low impedance, 8 ohms or whatever. So as I adjust the controls, you'll see there's a null there. The null on 10 metres is not very deep, but it is matching. Here we are changing the inductance. So I've now set the resistor at maximum. It's 2.6K on that trim pot, so I'll just try and null that out now. So here we go. I'll just turn the noise up, and I'll as you can see, it's nulling with almost no capacitance, which is what you expect at 10 metres. Add a bit of inductance. And it nulls over here somewhere. So the best spot is the minimum inductance. There we go. That's 2.6K load resistive at 28.5 megahertz. So I've now tuned the IC706 down to 160 metres, 1.85, 1.825 megahertz, and I'll try and match the 2.5K where the trim pot was last set on 10 metres. So just turn the noise up, and you'll see I've already matched it really. So this capacitor, C out, matches it. The input capacitor doesn't do much at that frequency, and I've got quite a lot of inductance in there, but I can reduce the inductance and the match gets a bit broader, as you can see. So that's 2.5K load resistor at 1.8. So I've now tuned the receiver. We're still at 1.825 megs, but I've reduced the resistance to 8 ohms this time, and here we have the match at 8 ohms. So you hear the null there. Just turn it up a bit. You'll notice I'm using manual. It's just a little bit easier for the demonstrations. So this tuning unit, although it's motor driven, I can also adjust the capacitors manually with these knobs on the front. Those positions of course won't be recorded by the processor. It won't know where I've tuned it, but it will reset itself. Once I do a reset, it'll go back to 0, and if I want those particular values, I can put them in automatically instead, and then I can then store what they were. Just one last test. This is 3.6 megs, and I've set the pot at 100 ohms. It's already nulled. You'll hear this. I'll just turn the volume up. And I'll just vary the inductance. With this particular type of tuner, the T-tuner, you'll find that it will null or match certain impedances on several different values of inductance. So, but however, you want to try and keep the inductance to the minimum, which is the least loss. The higher the value of the inductance, generally, the greater the losses in the tuning unit. So that's it for now. Just a quick demo of the range that this particular tuning unit can cover. That's resistive. I've done some reactive loads as well, 100 PFs and things like that. Has no problems matching that either. Here's my little 100 PF microcapacitor, which I've used for testing, and you can also of course use a variable capacitor. That's also quite handy to see what range of reactance, also in parallel or series with a resistor, see what range the tuning unit can actually accommodate. So this one is with that 100 PF capacitor at 3.6 megs.